In Up to this point in this unit, we've studied systems of equations where a solution is just one or two fixed points. In the rest of this unit, we're going to be moving into something called inequalities, where the solution is more than one value or a region or a set of values. So we need to review a few things you've probably seen in inequalities sometime before. We've got greater than or equal, less than or equal, and not equal. Those are symbols we use in inequalities. If you have an inequality in a single variable, something like this where there's just an x or there's just an a, then the solution is going to go on a number line. So we're going to look at reviewing how we graph an inequality on a number line before we move to an actual grid and a region of solutions. So first thing we need to look at is it says solve the inequality algebraically. We actually have to solve this inequality for x. So the first thing we're going to do is we're going to actually expand this. So negative 2 times 3 gives us negative 6, and negative 2 times x gives us negative 2x is greater than 12. Now 4 minus 6 is negative 2. So when we take negative 2 and we add it to the other side, we're going to be left with negative 2x is greater than or equal to 14. Now, next thing we have to do is we have to divide by negative 2. Now, when you divide by a negative, the direction of the sign changes, and 14 divided by negative 2 gives us negative 7. So, next thing we want to do is we want to graph this solution on a number line. So we're going to draw a number line, and we're going to put negative 7, negative 6, negative 5, negative 8, negative 9, negative 10. And it says x is less than negative 7. Well, something we need to remember from previous work is that when you have less than or greater than, then you use an open circle at that region. Now, all values less than negative 7 are these values that go to the left. So if we do a test case here, I'm going to choose negative 9 and put it in for x. Is negative 9 less than negative 7? Yes, it is. So that means we've graphed the correct region. So in this case, instead of having only one value for x, we've got an infinite number of values. All these values that are less than negative 7 are a possible solution to the question. Now, what we're primarily going to concentrate on is solving inequalities that actually have two variables in them. That means an x and a y, a p and a q. So we actually have to graph these. These are lines, and we're going to talk about those. So first thing we have to figure out is we have to figure out what's called the boundary line for the shaded solution. That means we actually graph the line represented by this equation on our grid. Now, something you need to know is that you have a solid line if you have an equals in your inequality, or you have a broken or a dotted line if you don't have an equals in your inequality. So there's actually some steps to graphing an inequality, and it says without using technology. That means we're going to graph this by hand. You can do this on your graphing calculator, but I find it really confusing to graph an inequality on your graphing calculator. So we're actually not even going to look at that because I find it confuses people more than anything. So what do we do first? It says on the coordinate plane, graph this corresponding linear equation, and we're going to graph it using x-intercepts and y-intercepts. So we're going to find the x and the y-intercepts, and that's how we're going to use it. Now, it says the coordinate plane is divided into two regions. So basically, if you have a line on a graph, you're going to have a region above the line and a region below the line, and those are called half planes. Makes sense. This whole thing is called a plane, so if you put a line through it, you're going to have two half planes. Now, to determine which side you're going to actually shade, we use something called a test point. The easiest test point to use is the point 0, 0. And if you plug in the test point, and if the inequality is satisfied, then the region which is shaded is the region including the test point. If it's not satisfied, then you shade the opposite region. And some of you are going, huh? What? What do we do? Don't worry. It's not as hard as it looks. It's not as confusing as it sounds. It's actually not too difficult. So we're going to start with these two graphs down here. Y is greater than x. Okay, so first of all, we're going to find the x-intercept. When we find the x-intercept and the y-intercept, we treat the inequality as an equal sign. When you find the x-intercept, you make y equals 0, because any point on the x-axis has a y-coordinate of 0. So if I take y equals x and I make y 0, tells me my x-intercept is actually at 0. Now, to find the y-intercept, you make x 0. So we're going to take our equation, y equals x. Remember, we get that equation by taking this situation and changing the inequality into an equals. Put 0 in for x, and we get y is 0. So in this case, and this happens only rarely, but it's good that we know how to deal with this. In this case, the x-intercept and the y-intercept are at the same point, and you need 2 points to form a line. And so what we're going to need to do is we're going to need to find at least one other point that lies on this line. You could do that by making a table of values. You could do that by looking at the slope of the line. I think the easiest way to do it is to just look at a table of values. We've got the equation y equals x. So I'm going to choose a few values for x. If I put 1 in for x, I get y equals 1. If I put 2 in for x, I get y equals 2, and 3 in for x, I get y equals 3. That makes sense because it says the y value equals the x value. So we have points at 1, 1, 2, 2, 3, 3. So there's points that lie on our line. So now what we need to do is we need to decide whether or not we're going to graph a broken line or a solid line. And remember, if this inequality has an equals in it, then that's going to be a solid line. In this case, the inequality does not have an equal sign on it. So what we're going to do is we graph what's called a broken line. You just put your ruler down and you basically make what's some dashes like this. So now we have our two half planes. We have the region above this and the region below this. And it then says use a test point to try and determine, do we shade above or do we shade below this particular line? So how do I decide which point to use as a test point? Well, I said the easiest test point to use is 0, 0. In this case, 0, 0 is on our line, so we can't use that point. We've got to use some other point. So what I'm going to actually do is I'm just going to go over here and I'm going to go over to 3 and 1. I'm going to use this point here that I'm putting an x at. And I'm going to substitute it into my inequality. This coordinate is 3 and 1. So in place of y, I'm going to put in 1. In place of x, I'm going to put in 3. Is 1 greater than 3? No. 1 is not greater than 3. So that means this region underneath this line is not our solution region because this statement is false. It means the solution region, and it's actually really easy to use a highlighter to do this, is this whole region above this line. And if you don't believe that that's the solution region, test a point in this solution region. A point in this solution region here is 0 and 5. So if I put 5 in for y and 0 in for x, yes, 5 is greater than 0. So because that's true, yes, this is our solution region. So let's do another one. In this case, first thing we're going to do is we're going to find the x and the y-intercepts. We're going to use 3x minus 2y equals negative 6. So we're going to find the x-intercept first. Remember, to find the x-intercept, you make y 0. So you get 3x equals negative 6. If you divide by 3, you get x to be negative 2. So negative 2 for x is where my x-intercept is. Now we're going to do the y-intercept. And remember, to find the y-intercept, you make x 0 and you solve for y. So you get negative 2y equals negative 6. So you get y is 3. 1, 2, 3 for y. So there's my 2 points. I'm going to be able to form a line. I need to look at my inequality. My inequality has an equals in it. So that means that this is a solid line. That means the line is included in the solution. And so now we're going to use the test point 0, 0 in our equation. That means we're going to put 0 in for x and 0 in for y. That gives us 0 on this left-hand side is less than or equal to negative 6. Is 0 less than or equal to negative 6? No, it's not. So that means this point is not in our solution region. That means everything above our line is in our solution region. So we just color it in. And again, if you're not sure if that's the correct solution region, choose a point in here. So I'm going to choose, let's see, negative 5 and 3. Well, let's test negative 5 and 3. 3 times negative 5 is negative 15. Negative 2 times negative 3 is positive 6. Well, that's going to give me negative 9 on the left side. Is negative 9 less than or equal to negative 6? Yes, it is. So I do indeed have the correct solution region. Okay, so it says in the next example to graph the following inequality without using a graphing calculator. So we're going to do the same things that we already did. We're going to find the x-intercept, and we're going to find the y-intercept. We're going to graph those things, and then we're going to use a test point to determine our solution region. So x-intercept means you put 0 in for y. So that gives us 3/4 x plus 3. I'm going to subtract 3 and get negative 3 equals 3/4 x. I'm going to multiply by 4 to get negative 12 equals 3x, and divide by 3, and I get negative 4 to be my x-intercept. So my x-intercept's right here at negative 4. Now I'm going to do my y-intercept. I'm going to put 0 in for x. Well, that ends up giving me y equals 3 because this is 0 and 0 plus 3 is 3. So 1, 2, 3. Now, this does not have an equals in it. So what we do is we line up our ruler through our points and we make a dotted line because that means the line is not part of our solution region when it's not equal to. And we're going to use the test point 0, 0. So I'm going to take y is less than 3/4 x plus 3, and I'm going to put 0 into this, or sorry, 0 and 0 into this. So this says 0 is less than 3. Yeah, that's true. 0 is less than 3. So that means 0, 0 is part of our solution region. So the solution region in this case happens to be everything underneath that particular line. Again, if you have a highlighter, it makes life really super easy to highlight in the region. Okay, last example that we're going to look at, it says, in the diagram, it shows that negative 2 and 0 and 0 and 4 are our x-intercepts. It says determine the equation of this boundary line and then determine the inequality. Is it greater than, is it less than, is it whatever? Oh, so we got to figure out the equation of this line. Well, remember, we can use y equals mx plus b, where m is our slope and b is our y-intercept. Well, we already know what our y-intercept is. We know our b value is 4. So that's easy. That's pretty simple to do. So I get y equals mx plus 4. Now I have to figure out what the slope of this line is. Well, I can count. Remember, slope is also the same thing as rise over run. So if I count this, I'm going to go up 1, 2, 3, 4, and I'm going to go to the right 1, 2. So that means for my slope, I have a rise of 4 and a run of 2. Well, 4 over 2 tells me I have a slope of 2. So that means this equation is y equals 2x plus 4. That's the equation of this line. Now it says determine the inequality. Well, what we need is we need to pick a point that's in our shaded region here. In this case, 0, 0 happens to be in our shaded region. I'm going to pick a point other than 0, 0 because 0, 0 will not always be in our shaded region, and you need to know how to deal with something if it's not 0, 0. So I'm actually going to pick 1 and 2. This point right here at 1 and 2. And when you determine your inequality, the point 1 and 2 has to satisfy the inequality. It has to make the inequality true. So what I do is I go y equals 2x plus 4, and I plug in this point. I plug in 2 for y and 1 for x. So I get 2. Now I'm going to leave out the equal sign. 2 plus 4 is 6. Now is 2 greater than 6 or less than 6? Well, 2 is less than 6. Because this is a solid line, that means we need to have an equals in here also. So what that means is we have to use a greater than or equal symbol in our particular equation. So our inequality ends up being y is less than or equal to 2x plus 4. We replace the equal sign with the inequality, and you decide if it's greater than or less than by looking at these two particular values. You picked a point in the solution region, and you want to make this statement true. So what makes it true is by using this less than or equal symbol. So there is our inequality, and we're done.